geometric mean. So this is the start of geometric mean. Well, the start of trigonometry. And this is technically not really trigonometry. Trigonometry starts in 10.3. Special triangles, I think, is considered trigonometry. And so 10.3 technically starts trigonometry. So the first two sections are just kind of triangles. Like I said, the Pythagorean theorem and geometric mean. In my opinion, this is harder. Partly because we're going to learn about two different kinds of triangles. No, we're not today. This is not that. That's special triangles. That's different. Today we're going to learn about different segments with legs, different names of a right triangle first. And yeah, but I wanted to show you guys this. This is how you find the geometric mean. Basically by multiplying two numbers together and square root them. That's how you find the geometric mean. Multiply the numbers together and square root them. Okay. Now we haven't. This is not the same thing as like if I wanted to find the average test score in this class. That's like an arithmetic mean, okay, or an algebraic mean. This is a geometric mean. Okay. This is how you find it. Any questions how to find it? So you're going to be given two numbers. You're going to multiply them together and square root them. Okay, so what I want to do is I want to go through this. Already done. See? Cool. Yeah. Should have just, yeah, you'd have been clear. Okay, so geometric mean. We're going to be finding out how to find the geometric mean of triangles. And I think the best way, I'm trying to think how I want to do this. If I want to show you, yeah, we'll do this here. Okay. Alright, this isn't going to make a ton of sense when you guys write down this stuff. I'll explain it to you. I'm just giving you a heads up. I know what the... So. Why is it crooked? Both of them. I'm going to start off with the top one. Okay, there you go. Tyson's just not here. What the heck? I know he was here during literacy. Okay.
Do you still live in Valley? That's what I thought. Hey, did you return on that white fan over
It's
there?
broken.
No, that one. Why do you have it?
That one. This one is too, though.
What? Why is it so hot in your bathroom?
I don't know. Look cool. You are wearing a sweater.
Yeah, because it's been cold out.
I know, but that, that's could be the reason why it gets very hot. You're just throwing out an example. You're throwing out an option.
What? What are you saying?
It's only 70 here.
That's like...
It's a lot warmer than usual. Okay, not warmer than what?
70 quiet.
Oh, I wrote
Usually it's like 65 during the shower here.
I wrote hypotenuse. Don't know why I'm
Just cross it out. She's ready to see. Sharpie.
Listen, hi. You're a little late. Hopefully we're still pals, right?
Dalton grabbed my Chromebook.
Grab your journal. Write down this box.
I forgot my
Alright, sit there quietly. Today's not your day. That's alright. We all have bad days.
Dude, my hand, my head already slapped.
To be honest with you,
Let's go, let's go, let's go. We don't have time, we gotta get a lot done on this.
No, but no place over there, I think.
Pay attention closely to this. This is called the altitude. This line right here, C to D, is an altitude. Okay, you pay attention. This is called the altitude theorem. The altitude, the geometric mean altitude theorem. Hopefully you guys wrote that down. So if you're looking for the altitude, this is the theorem or the formula, h equals the square root of xy, you're going to look for. This is the altitude. The next one we're going to talk about is the leg. This.
I'm literally
Get
not
over
even
here.
done with the first
Yeah.
one.
I know, I'm not going anywhere, don't worry.
I hope you understand that. I don't understand anything on
Me neither.
Yeah.
I have no idea what you're saying.
Remember what I said when I said you're not going to understand anything anyway until I talk.
No, like when we're writing is the easiest thing, I don't know what I'm writing.
And if I'm being honest, when you're talking, I just can't focus.
Yeah, but my
That's
it's like
all
so blank.
No, it's not okay. Guys, quit complaining. Tyson, you're late. You don't have to
Yeah,
say
Tyson, shut up.
Tyson, you have your turn.
Yeah, I found it. So
Good job.
yeah.
You know bathroom Tyson to do. Or Sam.
Sam, shut up.
Someone else for a change, maybe.
Hands, wake up. Write in the journal, man, hands.
He said, I cannot, I'm afraid.
Why are you afraid?
He's like, I'm afraid I cannot.
It's okay.
We're here. If you open your eyes, it won't be dark, so that would be like some fear gone.
Yeah, no, that's good.
It's not dark anymore.
I feel like I've been here all so long. I haven't seen that
Not long enough.
so long. Are you crying? That's not cool.
This is on.
Logan's going to
All right, so I'm going to start talking about this when I guys finish it.
We're not
Um,
to hear what you say.
Altitude theorem. First off, to identify everything in chapter 10 deals with right triangles. Everything. Well, I take that back. 10.6 doesn't. But everything other than 10.6 deals with right triangles. So it's important to identify that we're dealing with a right triangle here. An altitude is a line that goes from a vertex perpendicularly to the other line. And altitudes can look all kinds of different ways, right? I'm going to draw just a couple different kinds of altitudes over here so you guys can kind of see them. That's an altitude. That's an altitude. What's another one that would look real weird? So we're only dealing with right triangles. So yeah.
I hate this.
So altitudes are lines that go from the vertex perpendicularly to the other side. That's pointless. I'm not going to draw these. Okay, you guys ready? Getting closer. You can see a lot of you guys are on the last little bit there. Okay, I'm talking. So everyone listen. H considered the altitude here. Altitude, remember, we're just dealing with right triangle. So what would this side right here be called? What's the name of this side if this is a right triangle? The hypotenuse, right? So that's the first thing to identify. Listen.
What is that?
Hypotenuse is the longest side of a right triangle. Okay? So that is the hypotenuse. The hypotenuse is always across from the right angle. So where this thing right here is the right angle, the hypotenuse is always across from it. Okay? The altitude goes from the vertex to the opposite side perpendicularly. If this is how we find it, I wouldn't worry about this first part, but put a square around that one. H equals the square root of x times y. That's the one I want you to know. And that's the one you're going to have to know. So, knowing that, if we were asked to find h, we could find it by going x times y and then square rooting it, which is geometric mean, right? Two numbers times together with square rooted is geometric mean, which we just really talked about right before this. So, x times y square rooted equals h. Now, you're going to hear me talk about this, part 1 and part 2. This, if you think about this, the hypotenuse is split into two different chunks, right? Do you guys see this?
Yeah.
The hypotenuse has chunk x and chunk y. So to be able to find h, you would multiply x part 1 times part 2 and square root it. And that doesn't matter which way the triangle looks. If we have a right triangle that looks like this, and we'll just pretend like that's the right angle. If we have the altitude here, and we were looking for that, it would be this section right here times this section. Alright, so part 1 of the hypotenuse times part 2 of the hypotenuse. It doesn't matter how the triangle looks or what it is. That's the theorem, and it always works. That means that we can find the exact measure of that line right there, h, if we know what those two parts of the hypotenuse is. All right? Questions on that one? Does everyone have at least the formula?
There's no way that those two together.
Well, that's not a real triangle, Sam. I just drew it. Okay. Yeah, Sam. Trust the math, right? There you go. Next one. This one is the altitude. Now you're writing the leg theorem. Every right triangle has two legs. Every right triangle has two legs. They have two legs and a hypotenuse.
Breeze underneath the desk.
Came from the window.
Yeah, it's not up here, it's like down.
picture, so you're right. G52, 10-2,
10-2, yeah.
the geometric mean altitude theorem. Say it again? We normally would just usually probably have maybe some walk around there on the camp, but they're not gonna be fun.
Oh, wait, no, you're right. So that.
Right.
I finished.
I'm fine.
Hey, the two theorems I want you to circle are the two formulas. D equals the square root of xc, and A equals the square root of yc. Those are the two I want you to focus on.
Sam, don't watch me. Stop me.
He has got 1 minute, and then I'm going to start talking, so right quick.
I finished, Allie.
I think today, what I'm gonna do is I'm probably gonna find 3 or 4 problems on your homework today, and we'll do those, or maybe I'll find them out of the book, I don't know. Maybe we'll find them out of the book. Haven't you created it?
Oh, please be nice.
No, like 5.
He doesn't like us.
So,
Allie, it's hard, not 5.
what is up? Okay, this theorem deals with the legs, right? So every right triangle has 3 parts, 2 legs and a hypotenuse. This theorem right here does the legs. So what it is this. We can actually find the measure of each leg as long as we know what the hypotenuse is and what each part of the hypotenuse is. So meaning, if we wanted to find B equals the square root of the part of the hypotenuse it touches. Does everyone see how B touches X?
Yes.
Times the entire hypotenuse.
Right.
This leg would be A equals the square root of the part it touches. Does everyone see how A touches Y? Times the entire line. What?
I don't know.
Which is C, right? So B equals the square root of X times C. A equals the square root of Y times C. It's the part it touches times the entire line. Yes, Max.
Couldn't you, okay, so this is like counting this, but you have you have the altitude, and you have X or Y. Could you find the length of the leg?
By Pythagorean theorem?
Yeah.
Yeah, that's another way to do it. Yep. But I don't think any of the ones today will give you that option. Unless I think they usually give you like part of it, and like the whole line, and then they ask for that. So they don't give you another side.
Oh, okay.
Okay. So here we go. If I draw it, you draw it. Okay?
Well, I draw, you draw.
Alright. So, I want to find an example of one. Here we go. Here we go. If this is X, Y, and Z. So, first off, identify that it's a right triangle. Second off, identify this. So you need to identify a couple things right off the bat. Hey, you guys just got 5 extra problems. I'm not going to keep talking over and off talking. Remember, all for one, one for all. The whole front row. Minus there and there. For some reason, not there. I don't understand how. Okay? Alright, so listen. X, Y, and Z. Okay, first off, identify which sides are the legs of this. X and Z are the legs, right? This line right here would be the hypotenuse. Remember, we're not looking at these little individual triangles. We're looking at the big triangle in particular. So we know that this right here would be the hypotenuse. Now they're going to give us this. They're going to tell us that there to there is 5 and there to there is 20. Okay, so we're going to find these. First one we're going to find is X. X is a leg, so we're using the leg theorem. So the leg theorem says the part of the hypotenuse it touches. What's the part of the hypotenuse X touches? 5 times what? Yeah, the entire line. So it's the part of the hypotenuse it touches times the entire line. So X is going to equal the square root of 125, which, hey, you guys learned this. Do we plug those things into our calculator? No, what do? We factor, right? We factor it down and we simplify it. So 25 and 5, 5 and 5. So X is going to equal 5 square root of 5, and that would be the measure of X. All right, let's move on to Y. Y, question, what? No, so what, Sam?
The measure of the line is 5 square root of 5?
Yes.
Okay.
Okay. So Y equals.
You get an actual number,
That is a number.
but it's like, wouldn't the decimal ones be better?
No, because this would be a more exact answer than the decimal. You want to know what we'd do with the decimal? We would round it. This is a more exact answer than the decimal.
Why don't we just do...
So Y. Y is an altitude. So Y is going to equal part 1 times part 2. Right? So Y is the altitude. So it's the two parts of the hypotenuse times together. So that gives us the square root. That's just 100.
10.
Or 10.
Oh, I got it right.
Okay? Z. Can you guys see that if I draw it right there underneath it? Z equals the square root of the part of the hypotenuse that touches. What part does Z touch?
20.
20 times 25. So everyone go through real quick and simplify that one down. Is that Z equals square root of 500?
Yes, sir.
Yeah.
Oh, my.
So 105, 10 and 10, we have a pair of 10s. So Z is going to equal 10 square root of 5.
Wait, what? No.
Yes.
Yeah, you're right.
Okay, you're not going to have to find all 3 parts on your homework today. Usually they're going to give you one variable and you have to find one of the parts. Now, the parts, they may ask you to find a part of the hypotenuse, they may ask you to find a leg or an altitude. So we're going to do 2 or 3 right here off your homework. So everyone,
Wait, no, wait.
Okay, sorry.
Dude, after the 100, you break down 10 and 10.
Yeah, but well, think about what it gives you. It gives you a 5 and a 2 and a 5 and a 2. See how it goes right back to 10 and 10? Yeah, cool, huh?
Yeah.
Little trick. Here, we can actually just go right here. Here. So if we have a triangle like this, that's an altitude. We're going to say this is off your homework. So that entire line is Z.
You always tell us that, and that's not on homework.
Well, these are the kind of problems that are on your homework.
Oh,
And there's 4. So first off, we have to determine which one of the theorems are we using. Are we using leg or altitude?
leg.
Well, think about it. Look at it. Does it give us the altitude?
No.
Does it want us to find the altitude?
Yeah, no.
No. So we're not using the altitude. So we're going to use the leg. Now remember what the leg theorem is. The leg equals, leg is 4. Right? So the leg equals the square root of the part of the hypotenuse it touches times the entire line. So we're going to find it. We can solve this.
Algebra, dude.
Okay? Yeah, so we've solved radical equations in chapter 4. We're going to square both sides. 16 equals 3z. Divide by 3. Z is going to equal 16 thirds. What?
I did like 4 squared is 64 for some reason. I don't know.
Huh?
Okay, so look up here with me again. You just have to identify, first off, am I using the leg theorem or the altitude theorem? Whichever one I'm using, that's fine, right? This is the leg theorem. They don't ask for the altitude, they don't give us the altitude. We're not using the altitude theorem, right? So we're definitely using the leg theorem. Okay, let's do another one. So if they give us another triangle like this and they say this is 2y and 4, which theorem are we using? This isn't does it give us any of the legs? No. So it's the altitude theorem. The altitude theorem says the altitude equals. Yeah, but you have to use it to be able to find these parts because it's telling you need to use it to be able to get there. You can't use the leg theorem to be able to get y because we don't know what a leg is. So 4 equals 2 times y. Okay, everyone go through and solve that.
Hey.
So we're squaring both sides. 16 equals 2y, or y equals 8. Okay. So those are the 2 different examples. Now they may ask you for this leg over here. I'm looking through them right now, all your problems you could get. The funny thing is all your triangles are shaped just like this. I mean, they're different, like where the vertex
Alex
is.
is poorly made.
Yeah. There's a lot of people, smart people there. All right, here, try this one on your own without me helping. And then we'll go to homework. What? Yeah, try it on your own in your notebook.
Yes. Wait, were we not supposed to read algebra?
No, you are.
Okay, yeah, okay.
Okay, there you go.
This is not the same thing we just did.
It's the exact same.
What do you mean? It's the same thing.
Wait, at the end of it.
Yeah, that's an altitude, but there's no such thing as a hypotenuse theorem right now. It's either altitude or leg.
It's leg theorem.
Well, they definitely don't give any knowledge to knowing the
It's
altitude.
the
Yeah.
Pythagorean theorem, obviously.
So which one are you going to use?
Oh, this is easy.
Leg. No altitude knowledge.
There's no altitude and no leg.
That's what you're asking for.
This is
Wait, I'm
Easy. Square root of 14.
that's actually super easy.
Okay, here we go.
One is the easiest.
Now look, the way I know I'm using the leg theorem is because there's no knowledge about the altitude. They don't want us to find it. They don't give us the altitude. It's definitely the leg theorem. We solve it by going leg equals the square root of the part it touches times the entire line, or just x equals the square root
What if
of
it's
14.
weight and altitude?
So this is a good question, because there will be problems, you won't see them yet, but you'll see them later on, where they'll give you the leg and the altitude, then it doesn't matter, you can use either. But that's it, you just have to realize, first off, figure out which one you're using, the altitude or leg. They're going to give you information on it to let you know which one you're using.
Is that the whole section or just part of it?
That's it.
And this is the hardest one?
No,
Oh, you told us it was.
this is the hardest between 10-1 and 10-2.
No.
But it's like
Is anyone here?
the hardest section's 10-6. Law of sines, law of cosines. Yeah.
How many tens are there?
Yes.
So 10-6 is